5 to the minus 3 is equal to, we know this to be 1 over 5 to the positive 3. All we just do is change the sign, and our answer would be 1 over 125. 2 to the minus 4 divided by 2. Now this can be rewritten as 2 to the minus 4 times 2 to the minus 1. And this would be, the bases are the same and they're being multiplied, so we add the bases, so it will be 2 to the minus 5. And that would give us 1 over 2 to the positive 5. Final answer 1 over 32. 2 to the minus 2 plus 3 over 2 to the minus 1. So all we need to do is rewrite this down in its form. So we would have 1 over 2 to the 2 plus 3 divided by 1 over 2. Simplifying further, we have 1 over 4 plus 3 over 1 over 2. Clearly we can see this is a fraction sum, so we look for LCD for the top part. So we have times, this would be over 1, so we'd make this times 4 and times 4. So we have 1 over 4 plus, it would be 12 over 4 divided by 1 over 2. So we'd have 12 over 4, so it will be 13 over 4, and we can invert this and make it times 2 over 1. So we'd have 13 times 2 is 26 divided by 4, and then our final answer would be 13 over 2. So 15a to the power 1, b to the power 3, and c to the power minus 1 divided by 12, a to the power minus 2, b to the power 2, and c to the minus 3. Now what we need to do here is, we know that the rule is when the bases are the same and they're being divided, that we just have to subtract the top from the bottom. So let's do exactly what that rule says. And remember, the first part would be a normal fraction that needs to be simplified. So remember, we can look at 3 goes into 15 5 times, and 3 goes into 12 4 times. Thereafter we can write this, the rest of these terms in this form here, where we say a, which would be to the power 1, minus 2. So it's basically, all I'm saying is the top, a to the 1, minus the bottom. So remember, it's minus 2 times b 3 minus 2 times c minus 1 minus 3. So let's simplify this. We have 5 over 4, and this would be a 1 minus, okay, should be 1 plus 2, which is a to the 3. This will be b, 3 minus 2 is 1, and then we have c. C would be minus 1 plus 3, so it would be c to the power 2, and this becomes your final answer. In the next example, we have a squared minus 2 all raised to the power minus 2. So the easiest thing would be to put this over a squared minus 2 to the positive power, and we know that in the bottom we can clearly see it is squaring of a binomial. So we have 1 over square the first term, which is a to the power 4, First term times second term, which is 1 times minus 2 is minus 2, times 2, which would be minus 4, a squared, and then we'll have plus 4. Eight to the minus 1, a squared, b to the minus 2, all over 2ab to the minus 1, all raised to the minus 3. So the first thing we'll do is to move these terms, because they're being multiplied, we'll move these terms to get positive exponents. So 8 can be placed at the bottom and become to the power 1, positive power. And the a squared will remain in the top. The b can come to the bottom and become b to the power 2. And then this denominator here can be moved to the top, 2ab to the minus 1 and to the positive exponent. All we need to do now is to work with the bracket. So we have a squared. This will be 2 to the power 3 is 8. a3 and b minus 3 all over 8b squared. Thereafter we'll multiply through. We'll have 8 a to the 5 and b to the minus 3 all over 8b squared. So all we need to do is the 8's cancel off, and we're left with a to the 5 times b to the minus 3 minus 2. Right? So we'll have a to the 5 times b to the minus 3 minus 2 is minus 5. So my answer would be a to the 5 over b to the 5. In this next one, we have n to the power 2, p to the minus 2, multiplied by n to the positive 2, and p to the minus 3. Now remember, the bases are being multiplied. They are the same. So we will add the exponents. So my next step will be n to the 4, and this would be p to the minus 5. And then all I need to do is put the p at the bottom, so I'll have n to the 4 and p to the positive 5.